Good morning to everyone. I believe that all of you are teachers in engineering colleges, right? And from states like Orissa, I was told, and then Rajasthan, and any other state? Bihar as well. Okay, excellent. So, just to be on a lighter side, this is a holiday, so I would begin with a lighter side. Do your students wait when the teacher is late, little late? Because I want you to be thankful to you because I was late by 5 minutes, you know. So, these are some of the perils of living in a modern world. Sometimes lifts work, sometimes they don't work. So, I got caught up in a lift. Yeah. So, anyone else is coming or this is all the group? Okay. All right. So, what I am going to do is I am going to walk you through a path that I had taken, and on the way I have collected some experience on doing technological work in the domain of agro-food processing, agro-food engineering, agro-food technologies. And at times I will capture you where was the stem, where was the stem? You know what is stem? What is stem? Anyone else? STEM, S-T-E-M, S-T-E-M. Right. So, STEM is like, here we say is science, technology, engineering, mathematics. Science, technology, engineering, mathematics. So, at times I will try to sort of connect you to Perry's, then I will try to connect you to, the physicist, for example, who gave us the Peltier effect. So, Perry's, Peltier, and Ramanujan, who gave some mathematics, right. So, it is STEM, science, technology, engineering, mathematics. I may explicitly do it, sometime it would be sort of implicit. I would let you sort of see that where was the mathematics in this, where was the technology in this, where was the engineering in this, and where was science in this. Okay. So, the time allowed to me is an hour, right, is that correct? Yeah. So, we will have more like question and answers, and in the meantime he is doing that. I will, as I said, not only will walk you through these case studies that I have done as a part of work here in the center to which I am associated academically is Center for Technology Alternatives for Rural Areas, CITARA as it has an acronym, as well as TCTD, Tata Center for Technology and Design. But what I will also tell you, Gayatri always looks for something new. So, what I have added new is my own transformation from BTech, MTech, PhD to a Prof here. So, what I have tried to sort of give you, for example, what was my BTP, what was my BTech project, what was my MTech project, what was my PhD project, and for example, what were the level of sort of connectedness with the problems that are thrown, technical problems that are thrown by our stakeholders, right, because you must have heard about our philosophy or methodology at Tata Center of end-to-end innovation, right. You identify a problem in the nearby vicinity community, because that is what is, I feel, role of a engineering and technology institution, as to sort of identify what you see around, keep your eyes and ears open. Sometime I think we have a colleague in IISc Bangalore, he used to say that sometimes Indian Express Times of India are also our interlocutors. You hear those problems within those newspapers also, and be conscient of that, and sort of develop. I mean, you will see in the case studies how we, for example, had heard the stakeholders talking about some issues. It could be a drudgery, it could be efficiencies, because as engineers, I guess all of you are engineers. Anybody from science? Most of you are engineers, right? All of you are engineers, right? Yeah. So, what we need to be, I mean, like what engineers are fascinated with efficiencies, numbers and all that, right. So, when we see that certain things can definitely need not stay below 10%, 15%, we would sort of want to sort of put in our numbers, like, I mean, we have theoretical limits, like IC engine, for example, you can never ever achieve more than 33%, right. 1/3 of it has to go in its exhaust, right, you can't do anything there. Um, yeah, okay. Yeah, and what I would like to sort of, time to time, in addition to the STEM that I talked about, also I would like for you to see implicitly, hidden within, how, for example, we draw upon the science and technology and domain of knowledge in different disciplines, right? Often at times we tend to create silos within ourselves that, well, I am a mechanical engineer, why do I have to look into sort of, electricity regulation issue in a rural area, when you have the power fluctuations, for example. Yes, why you have to look it? Because like you are sort of doing some technical intervention, let's say as a refrigeration or a thermal engineer, and so I hopped actually from the lift. That's why I was feeling a little thirsty. So sorry about that. So as a thermal engineer, for example, you want to store certain things at a ideal temperature, right? And what are those ideal temperatures in agri-food? For example, it is commodity dependent. Thank you, sir. It is commodity dependent, and therefore then, see, for example, everything we don't put it in the fridge, right? You have a fridge in the house, you don't put bananas inside the fridge, right? You put bananas in the fridge? No. What happens is you get a cold injury. Now, where does that come from? It comes from a science of post-harvest physiology, right? There are these agricultural scientists who have, and so some of these knowledge is empirical knowledge. So, other commodities like grapes, for example, apples would be better stored inside if you provide a vapor compression system that all of us use these days in a domestic fridge. So, so this you try and seek what is the sort of a knowledge coming from a discipline. So, as I was saying that you will see for the seed storage unit that we had used was a little deviant of a domestic fridge. Domestic fridge works on a vapor compression system, refrigeration system. This one works on the Peltier effect, and which is called TEC, thermoelectric cooler, which is exactly reverse of what you see thermocouple. Just raise hand, how many of you have seen a thermocouple? Right, what does thermocouple do? Because of this temperature difference, of course there is some cold water potential. So current is flowing and we can calibrate it to right. Some millivolt is generated as a due to delta T. So that delta T between two dissimilar metals, then you have K type, J type, chromel alumel, copper constantine and all these kinds of things you join together and you expose it to, let's say I want to measure a temperature here in this room. So it would be something like 24, 25 degrees Celsius, right. So I want to measure it here and what it does is like, this delta T generates millivolt and then you sort of, calibrate or you sort of do a calibration that what millivolt correspond to what temperature and you get a display. So that's how a thermocouple works. So this Peltier effect we exactly did, reverse of that. What we did was we provided millivolts at the other end and got delta T inside. Because let's say for example, I want to keep as I said certain commodity and we will see for example, so that's my email ID. So we will see when we talk about that. So just allow me to take 10 minutes to tell you about my own transformation. So which you can use either for yours or your students who have come for your BTechs and then subsequently they want to go for a further education or something like that. Keeping in constant touch that we are just not producing students with engineering degrees. By the way, it's one of the industrialists some 3 or 4 years back came in the newspaper also. He said only 10% of the engineering graduates are employable. That puts a huge responsibility on us as teachers. Are we producing 90% engineers who are sort of, industry does not find employable? I think there is a cause of concern, there is a worry. And I think here is an opportunity that in addition to teaching your courses, you can do something. So I'll just quickly sort of, tell you, this was my BTech problem using vertical Helesha model, for example, to mouse. You have a mouse, external mouse? Ah, I got the link. Yeah, I got the link. Yeah. So this was, for example, the vertical Shah model that I constructed as a part of my BTech work. And the idea was sort of, if anybody from civil engineering, you are from civil engineering. So what happens is you want to study underground flow of water. And in agriculture domain, what happens is, like they say, drainage is as important as irrigation. It's not just enough to sort of give water, but it also, soil, when you define, soil has to have something like 30% of air. So if the soil is inundated with water, only a crop like paddy can stand, for example, right? Paddy is rice. So rice can stand inundated soils, but most of the soils, if you want to sort of characterize them as soil, you must have a porosity or a air volume of something like 30%. So if you do not drain immediately, the crops would be suffocating. So therefore drainage is important, and we wanted to see, for example, the flow of, based on the soil, types of soils. You have clay soil, sand soil, and clay or medium clay, and all those kinds of porous medias. And how does, for example, the underground water flow takes place. So we had a vertical Shah model, something like this, we had simulated, and the maximum number of differential equations that I would have used in my life was during my BTech project. Now I don't use that many. So I am just wanting to narrate to you actually my journey, how, for example, me as a researcher, through my initial engagements in research. So this was my, for example, master's project. Okay. So immediately after my bachelor's, for 1 year of experience, I went for my master's, and I was working for my MTech project on something for the wetland paddy. What happens with wetland paddy normally is the machines get bogged down. Okay, as you can see here, instead of the rubber tires, people put cage wheels, as they call it. So they allow the tractor to float. You can imagine that such a heavy equipment, it is bound to get bogged down into the paddies, because I don't know if anybody of you have seen the exercise of transplanting. Anybody has seen how the paddy, the seedlings of 3 weeks, 21 days, they are taken and then transplanted, right? So you have, let's say if you have a 2 acre of farm, what you do is, in a small part, you have some kind of a nursery, you grow, for example, these small bachu seedlings, and then subsequently after 3 weeks you transplant. So that's a method of transplanting. So when you transplant them, you really have to go to fields which are muddy, because the seedling has to just be posted there and sort of. So what happens is, those people who do it manually, they have to work in a knee deep mud. So as engineers, as I said, when you keep your eyes and ears open, you also see the drudgery involved. The laborers are doing this kind of a drudgery, that they have to do this. So the question that in my MTech project I had was, can you sort of, if you have this small, either a tractor or power tiller as it is called, right? Some of you would have seen the power tillers. It's called walking type tractor. Chota tractor hota hai, there's companies like Kubota, and I think in Tamil Nadu there's a company, Yanmar, and Japanese, Chinese, and they are the ones who have been sort of mostly making it. So you can see this is a walking type tractor. So what happens is, it's light in weight, and it can do, because since it's a wet soil, the drag forces are not too high. You don't have to really push through, like you don't need a 35 horsepower machine. You have something like 4, 5, 7, maximum 8 horsepower machines that are on this. The problem here, for example, that point in time, I did sometime around 1981, 82, right, and my MTech. And the problem I was asked to do was, like, simulate this again in what you call as a soil bin. So I constructed, say, for example, a width of this from here to here, and that long up to the end of the seminar hall. So I constructed a soil bin. I then put in different types of soils, as I say, clay soil, sandy soils, and change the soil, and measure the drag forces. So as you can see here, for example, is something on y-axis, something on x-axis. What you see on y-axis is the drag force in newtons, and on x-axis, for example, is the distance of travel. Okay, distance traveled. Okay, what the idea here was to measure the drag forces. So, the important element here of my MTech work was to sort of devise a dynamometer which can measure the forces required to pull some attachment that you have. So, I had the flotation attachment. So, I have the floaters, for example, different types of effect of water film on drag force of a flat nosed float on soft soil. And what did I draw upon? I drew upon something that people use in skiing. Have some of you seen, for example, in ice, if you go on the hills, you do skiing, you have something nose up, right, something like that. So, again an interdisciplinarity that I looked into the literature, how, for example, the ski equipment was designed, what were the drag forces. So, one of the important contributions that I could make was there has to be at any point in time the water film there. So, which will sort of, you know, if there is no water, your drag forces would be very high. So, that drag forces apparently helps you to design on the tractor power, what power engine you put there and things like that. So, that was my MTech. And look at what was my PhD problem. I went to France, for example. In the first month, when I have an interaction with my professor, he tells me, well, you have worked on Elisha models, you have worked on design of gasifiers, or you have worked on sort of design of things. This is what you have to work on. This is what a research problem he gave me. I said, what is there to do a PhD research on this? You have a mound of wood, right? A mound of wood is collected, and the objective is to convert this wood in given batch time to something which is called charcoal. Charcoal देखा सबने आपने, wood charcoal, right? वो भुट्टा को बनाने के लिए जो charcoal use करते हैं. That, you know, you have any idea what in Mumbai, for example, we pay per kilo of that charcoal? Go in front of H1, for example, you have a guy who sells bhutta. Ask him. I don't know where they are staying. They are staying in guest house. MTNL. Yeah. So you have an idea how much, what could be a cost. I mean, you can guess. You don't. That's little higher on estimation because 40 rupees is gehu or chawal. So not too far. It's something like 20 rupees he pays per kilo. 18 rupees. So about 20 rupees. So I, for example, could never ever imagine that, you know, at times there was time that the charcoal was more expensive than grain. See, PDS में आपको public distribution system में rice and chawal you get it in sort of, you know, Andhra Pradesh was the exception, 1 rupee per kilo subsidized, but you have to pay more for fuel than food. That was the kind of, so he said this. Then something like 2 to 3 months I did sort of, you know, worry about as to what is there, for example, to do. And then subsequently I come to understand that the kinds of problems existing in this mound kilns, the efficiencies are of the order of 10%. You know what it means is if you have 100 kilos of wood which goes into the kiln, you get only 10 kilos of charcoal. In this kinds of mound kilns, you have that kind of 10% of, so huge scope for improvement. Huge scope for improvement, and that's what then, you know, simple things like, you know, so in addition to establishing for my academic work, as PhD work, I had to establish whatever was the heat and mass conversion efficiencies, balances and all that. But one practical question which the artisanal master craftsman was facing was like, what should be his initial moisture content of the wood? So if you see on x-axis is the moisture content of the wood. So freshly cut wood is having something like 50% moisture. If you go cut a tree here, not allowed by BMC, for example, does not allow IIT to cut a single tree here. You don't allow it. It's very, very powerful. But let's say, imagine if you are in a forest, you cut a wood and you measure the moisture content of that wood. It could be something in the order of 50 to 60%. So can you put that directly into the kiln? It would be easier, you know, drying again cost is one of the very, very energy intensive exercise. That if you have to dry wood, requires long time, lot of energy is required. So people take shortcuts. But if you put 50%, you can imagine, that's what explains then why you have the efficiencies as low as that. People just cut it, you know, within 2 weeks, 3 weeks, they'll go and put it inside the kiln. Efficiencies are bound to be low. So this was something which I established, published and all that, you know, like at that point in time, that as you have higher the moisture contents, your charcoal fractions are going to be smaller and some few things like that. And I see that I am seeing a transformation in myself. I am not only writing differential equations, I mean here also I had to write those equations to sort of, you know, satisfy the academic community as to sort of, then we did few things like we took, for example, a small simulated batch kiln, not as big as what you have seen in the mount kiln where you have 25 tons of wood. So, I just took a 1.5 ton kiln, put it on a balance, okay, put it on a balance, did physics and chemistry of that. When I say physics and chemistry, what it means is as a function of time, I just saw how the weight is going down, right, how the weight is going down. What was the temperature inside the kiln and what was the chemistry of the emissions? Because when you say a partial combustion kiln, actually, sorry, I missed you the title there, perhaps no, I am not getting the titles there. So, oh yeah, it's there. Okay. So, it was study of partial combustion kilns for optimal charcoal making. So, what it means, partial combustion is part of the wood, part of that charge is burned to give that, because it is endothermic reactions, it requires heat from somewhere else. So, you burn part of the wood to convert into sort of do all your pyrolysis reactions and all that. So, I did chemistry of those effluents. So, I had physics, as I said, by putting that on a thermal balance and measured, for example, the effluents as a function of time, and was wanting to sort of one of the important question there, the the charcoal kiln makers were asking as to what point in time to stop. I mean, something what you call in this is an empirical science, something has come from practice. Okay, that if you are using oak kind of a tree, for example, with that much of moisture, it will take 3 weeks. But here at least you can see, for example, how it is shrinking and all that. People have shifted from such mold, the mound type of kilns to metallic kilns, right. In Europe, for example, you use metallic kilns where you do not see what is happening inside. So, how do you find, for example, whether it is 16 hours, 18 hours, 24 hours, when do I stop? So, then I correlated something with the chemistry of the effluents and got to something. So, this was, I feel, one of the sort of transformation that I had, that how you can sort of be as close as possible to the stakeholders, and that is one of the mandate at Tata Center. You must have been told that we would like to work on end-to-end innovation and trying to see what role as a technical institutions and universities we have. So, one, we say that I have put it in 3 statements. One is provide alternative solutions to the questions posed both by public and private sector decision makers. Okay. Then academic institutions can create evidence through research and knowledge that is unbiased, right. So many a times you can say, for example, I am talking in terms of storage of grains, okay, be it food grains or seeds or whatever. There could be a company which is in a plastic manufacturing. So, they will say only these plastic bags called grain pro bags is the best solution. They can come out and make a statement, but there is a conflict of interest, right. Whereas an academic institute, therefore, for example, at IIT we have a cell called IRCC, Industrial Research and Consultancy Cell. Every day there would be at least 15-20 of letters coming from these stakeholders like corporates, government bodies and things like that. Can you do this kind of a consultancy assignment? They want an independent view. Is the Parel Bridge going to fall down? For example, they want to do a structural analysis. So, it would be something what you call as unbiased. So, that's, I feel, is one of the roles that the technical institutions have, and of course, one of the most important is creating manpower that has skill sets to engage in development backed by STEM based solutions. That is what we talked about. And the mandate is, many of our communities are resource constrained and they are hungry for ways to create livelihoods, and solutions need to be efficient and scale appropriate. For example, one of the work that I have been doing is in Tata Center is on nutrition, right. I was given a problem by the ICDS secretary here who sits in Mantralaya. She said that, look, here is a community called Dharavi. How many of you have heard about Dharavi? Dharavi suna? Asia's biggest slum actually. It's a very small 2 km square area, but so densely populated, and we have something like 300 Anganwadis there. So, normally in the villages you have one Anganwadi and in the vicinity of 10 kilometers there would be none. But here in 2 km square, because of the population density, you have 300 Anganwadis. So, she said, like, can you formulate something for, some category of children who face malnutrition of type SAM and MAM. SAM is severely acute, MAM is moderately acute. Okay, some very, very bad condition, and then that's where we use our mathematics, for example, that you know, how do you categorize them, and we will perhaps come to that when we see that case study. But the problem here was sitting at an institution like IIT, we can't, you know, each Anganwadi has something like 60 to 70 kids, 300 Anganwadis, 21,000 kids. Where do we have a lab to make the food for them? And if at all we sort of, you know, recommend something from the science of nutrition, that it has to be sort of whatever calorie rich, protein rich, micronutrient rich, whatever is coming from that. And we had actually a municipal hospital, a pediatrics department associated with us, and they say that yes, okay, and in this age group from 6 to 60 months, for example, the child needs this is, I mean, that's the sort of, you know, group, like between 3 years and 6 years they go to Anganwadis. So between 3 years and 6 years, what is the kind of food that you give? So now that food has not only to pass the criteria of nutrition basis, but also it has to be tasty, otherwise why the bachchu would eat? You know, why the bachchu would? Because the ICDS secretary knew it, that whatever currently government is making and being distributed in each of districts of Maharashtra, for example, I think the same would be the case in other districts, Rajasthan and Orissa, where you come from, that these foods which are distributed called THR, take home rations, for example, for the kids, they take it from the Anganwadis, you know, and go home and give it to the animals. One of the reasons was it was not tasty enough. Now, as I said, they are the solution hungry, but there is also an issue of funds. Government says that we have only 10 rupees maximum for a moderately acute malnourished child, 15 rupees maximum for severely acute malnourished child. So now, how do we sort of, you know, devise something which meets these kinds of stringent requirements? Because we can do at a Tata Center, IIT Bombay can do only a pilot project, can only demonstrate the efficacy and all that. So as I said, like, you know, for an academician, what was the research question there? So for someone like me, for 300 Anganwadis, how do you choose them? So then there is a statistics, you know, there is called as sampling, you know, powering of sample. What is the correct sample which represents the population? How do you do that? So there is a way and all that, okay. So, so this I have already said, something about Tata Center and about Sitara. So this also I think Gayatri would have shown you that we work on 5-6 different domains: agriculture, food, education, energy, healthcare, waste management. So these, for example, are the subjects that I teach here: soils, agriculture, agro-based industries, food processing, and of late nutrition. So see, for example, one of the maxim or the principle that we grapple with, we always say small is beautiful. You know, there was a British gentleman called E.F. Schumacher. He wrote a book called Small is Beautiful. Okay, small is beautiful. It doesn't seem, the size doesn't seem to be leading to those kinds of productivities. Look at this, for example, all these numbers seems to be at least 2.5 times higher. All these numbers. So the question remains, the science and technology community is grappling with size of holding and efficiencies. What normal understands as humble engineers we would have is like, if you have a smaller unit, you would be better managed or something like that, right? But doesn't seem to. So we have these production difficulties. So in addition to these production difficulties in agriculture, you have some post-harvest loss issues also. Look at this diagram, look at this cartoon, for example. What does it tell us? That in the whole supply chain that you have, you know, from the farm to fork, they call it, this is farm to fork, to consumer. And in the supply chain, you have various losses. So you have from transportation from the farms to your whatever, you know, Taluka Mandi, from Taluka Mandi, it comes from like Sinnar to Nasik, Nasik to APMC, it comes in Vashi or Mumbai, for example. So there is some qualitative loss as well as some quantitative loss. Okay, and what we tell our students here, you don't have to go too far here, you just have to visit the Baikala Mandi or a Vashi in APMC. You see that all that is grown by the farmer with so much of, you know, scarce resources like soil and water and his own hard labor by the farmer. I told you about the paddy person, grower, that he has to walk into the muddy fields with his knee deep mud. that kind of a difficult soil. So he has put in all those efforts. Where is it going? If you look at the MOFPI, there is a Ministry of Food Processing Industries in New Delhi. They have a website. If you go to their website, documented something like 25 to 30% is a loss during the post-harvest supply chain. Now that's colossal. You take small countries like Malaysia, Philippines, they would have come down to something like less than 10%, 7%, 8%. Why can't we do it? So you have production some issues, you have the post-production issues like what we call post-harvest handling. Can we do something like that? So as contributions from a technology institutes, that's what I have said that we want to sort of. So these are some 4 case studies that I want to touch upon. I may not, with time allowed, perhaps I will be able to sort of go into the details of maybe 1 or 2. And so one is like the first case studies I will present you about the cultivation and post-harvest technology in Mogra. Jasmine, sabne dekha hai Mogra, right? Mogra flower. So what was happening was 10 years back, you would have the cargo full planes coming from Bangalore to Dadar market. There is no airport in Dadar. From Santa Cruz, they would go to Dadar. But they have to reach, the Mogra has to reach by something like between 5 to 6 a.m. Okay. So what happened was one of the superintendent agriculture officer who really was a very meaningful officer and introduced this 10 years back in a new district called Palghar district, which is carved out of a big district called Thane district earlier. And he said that, well, if the Mogra is coming all the way from Bangalore, why not the farmers here, who have a land of 1 acre, 2 acres, half acre, for example. And this Palghar district is something like 95% of it is tribal. A very sort of, like no livelihood opportunities other than one single crop in a year. They just take paddy once. What do? They migrate in the seasonal. So once their Kharif is over, like June, July, for example, when they have to really plant the rice. Once that is done, rains will take care of it, and they would just migrate to cities like Vasai, Thane, and all that. And do the. So if you, for example, as a technologist or as an engineer or as a scientist can provide some alternative way for them to earn something, this temporary migration could be stopped. So these are what you call as spin-off. So that will be a case study that I will present. Then there is something on storage unit that I have said. Jaggery, I don't know whether Prof. Mahazani covered it or he'll speak tomorrow. So I will sort of keep that for reserve then. That there is, all of you have heard about jaggery, right? Good. Right? No, you have heard about jaggery, right? Yes. So good is a good sweetener. Good is a good sweetener. Why so? Because compared to the refined white sugar, we have retained, because it's unrefined, we have retained some minerals in it. So jaggery is rich in sort of calcium, iron, for example. So it was our forefathers had the wisdom. For example, if you are in Rajasthan, in hot summer you come from outside, ghar mein jate hi, what they would give you a glass of water and a small piece of jaggery. Because what happens is when you come from hot sun, your mineral balance in the body disturbs. So you want to sort of, so perhaps they did not know it, this kind of a, composition of the chemistry and all that, but they had this wisdom that, jaggery is something good. So its nutritional benefits, there is a clear evidence in the science of nutrition that this is better than the refined white sugar. So that's the case study. We will see if time allows, we will see that. And then there's something on, as I said, the Dharavi based work. And mind you, all of these case studies, for example, there was a student associated. That's what I want to bring to you as teachers. That in your own research, in your own R&D work, if you can associate some student, it becomes a learning for him. All of these are sort of, so this and this definitely are offshoots of our Tata Fellows who do MTech here. And this was part of a PhD student of mine and Professor Mahazani together. And this is again sort of, one of the students who is graduating now next month, who did part of her photo. So it becomes some kind of, as I said, the little obligation that we are with, that we are creating a trained manpower. Can we use these project opportunities for them to learn? okay, for them to, they will fail, for example, sometime, doesn't matter. Professors also fail sometime in this. When you are doing the real life technical problem, you may fail, but this allows us, these projects allow us to do these kinds of things. So, let me sort of take you to this and I will narrate you through, for example, a video film. If you can help me. So, I will narrate, so this is narrated very well narrated right from, as we say, end to end. So, there is a problem identification as to why we chose a problem. You remember the title of my talk was choosing a research problem. How do you choose a research problem? What to work on? So, for example, here we
Mogra is a high-value ornamental flower often seen adorning women's hair and used in celebrations across India. Of all the cultivators of Mogra, Palghar in Maharashtra ranks highest in the state's production. As outreach, about 90 to 95% of the Mogra flowers retailed at the Dadar flower market is cultivated by the tribal farmers of Palghar. Data also states that in summer 2018, about 10,000 kgs of Mogra were retailed in this market every day. This decade-old cultivation initiative has been formed by a cluster of farmers and has provided an alternative source of income during the non-monsoon seasons. Since 2004, Mogra cultivation has contributed to the arrest of seasonal work-related migration of farmers to near urban and urban areas to some extent. They were reported to have migrated to Vasai, Virar and a few suburban areas of Mumbai before this activity. Since 2012, the same problem of farmer migration was seen to have resurfaced. Here, the possible role of the cold storage technology intervention to achieve high quality produce with unopened and white colored buds was identified by the team from IIT Bombay. In an effort to understand the problems and constraints faced by these farmers, a design-based exploratory study was conducted as a part of the master's program by Srinit Rathi, a Tata Fellow from IIT Bombay, under the guidance of Professor Narendra Shah and Dr. Suhas Zambre. The Collector Office at Palghar and Tata Centre for Technology and Design, IIT Bombay, along with local support from NGOs like BAEF at Jawahar and Swaraj at Mukhada, have carried out the field project to test the cold storage initiative and analyze the income effects post the intervention. The post-harvest technology for Mogra cultivators was developed after several levels of interviews, discussions and feedback from all stakeholders such as the farmers, traders, collection centers and the middlemen who act as transport operators. The pilot trials from February to June 2018 have established economic patterns which indicate a reasonable payback within a year. This intervention has enabled the Mogra cultivators to help store the harvested Mogra produce in the cold storage unit for the day in case the quantity is not viable enough to be transported that day. The cultivators now also have the bonus of added time to their Mogra plucking hours. What used to end at 7:30 am has now been extended to 11:30 am, thus offering 4 extra hours for plucking the entire harvest with this storage facility. The ability and time to grade the Mogra between bold and normal categories is thus available to the cultivators. Further testing during the winter months from October to February will involve replicating the intervention with the same set of farmers in coordination with the field actuators like NGOs and government organizations. This should help disseminate the technology. As a part of the SWOT analysis, the IIT Bombay team anticipates a constraint which is outside the scope of this intervention: water availability during summer for Mogra cultivation. The hope is that this challenge can be overcome with sufficient inputs from the stakeholders. With this solution developed, The Mogra farmers can now increase their plantation area by up to 300% without being constrained by the market linkage problems. The Centre hopes that this cold chain based value enhancing technology intervention can be walked through to the next level.
So, like I asked you a question earlier, was what was the price of charcoal per kg? So, what do you think? I mean, the Mogra is also sold on per kg basis. In the other market, for example, these days, what could be the price of Mogra? Any guess? These Mogra buds, jasmine buds, are sold at certain rate per kilogram. What could be the price? Yeah. So, we have two estimates here, 100, 400. If you go tomorrow early, if you are courageous, you can get up at 5 o'clock in the morning and go to the other market. You will find that it is sold at 1200 rupees per kilo. What do the farmers get? 40 rupees per kilo. What is the distance between Dadar and Mukhada or Jawahar, the areas we talked about? 120, 130 kilometers from there. So, look at this, I mean the kind of outgo to the farmers is what percentage of the price that they sell it in the market. Okay. So the exercise here was, for example, how do you remove drudgery? Again, I talked about paddy. Now, the drudgery here was if they have to reach the Mogra at 6 o'clock, they have to get up at 2 o'clock, 3 o'clock in the morning. So, you saw something, there was some headgear, right, headlamp, and that can be solar powered, for example, if, and then we said that why, for example, not we design something which will allow them to store this Mogra for 12 hours, 13 hours, and then they can take it next day, right. So, can we have a decentralized cold facility, and that was one of the, so we had actually three different interventions in this. One was ergonomics, right. So, we said that tea pluckers, for example, you know those you must have seen in the films that nobody is from West Bengal here or something. You are from Assam, right. So, those ladies put something behind and their both hands are free. What these guys used to do was they would take your mobile, so here is a mobile. So, they would take their mobile, put a torch by one hand and other hand is engaged in this. So, why can't we have both hands free, a simple device which exists, the miners regularly use, right. So, we intelligently sort of, so one was ergonomics, and then second was this cold, so that they can sort of get up at regular whatever 6 o'clock, 7 o'clock, and during this 7 to 12 o'clock they can pluck the buds and then keep it in the cold and take it for the next day, so that they can make it reach 4 o'clock also in the morning, 5 o'clock at the other. So, so these were the interventions in this, and we see that there is some kind of a feedback, and the project is still ongoing, and as you have seen, sorry, so this is a plucker here, as you can see, this was designed as a part of this work, and this is the headlamp, you can see, because you can imagine number of things, like this particular student he stayed for 2 months of during his MTech time in this village, and he found that there was a case of a snake bite. In the early morning, for example, it is very likely that you would have that kind of a simple solution like this can also work, and this was the cold solution. So, not only for storing on the sort of in their houses, but also during transport, like milk is transported. For example, in Mumbai receives milk from Kolhapur, or Baroda, for example, the Amul milk comes from there and Gokul milks come from Kolhapur. So, about 250, 300 kilometers, if it comes in a refrigerated condition, you have, those are called refereed vans, they call it, or the bulk coolers. So, can you not sort of, 120, 150 kilometers, can we not have those Tata Ace little ones? And they can have the, as an institutional mechanism, some FPOs, FPCs, for example. I mean, these are some schemes like NABARD, for example, offers them that you can form a group which is called FPO, Farmer Producer Organization, and then they give some kind of a subsidy to sort of buy a ACE truck, for example, a small truck ACE I am mentioning about, and you can have these transport boxes, and it can be kept cool during the transport also. because 120 kilometers in this barish ke season mein when there are a lot of potholes can take 3 hours also, right. So all that was part of this. So there is some data here, and also for example we had something what you call decentralized. We actually adopted a solution which was existing by a company called Chotu Cool. If you Google for example for Chotu Cool, it will tell you. So they did not succeed too much in their fruits and vegetables thing. So we said that later. So this has the volumetric capacity is 35 liters, whereas what we have done as a centralized solution like 10, 20, 30 farmers can own a 200 liter chest cooler, you know, as for example, if you go to any ice cream shop, you see a baksa like this, right? In ice cream shop, you will have something like that. But in ice cream, at what temperature do we store ice cream? Minus, right? Sub-0 degree Celsius, sub-0. Here we don't require sub-0. I mean, you might do a cold injury also to the bud. So what literature tells us, like, so for example, I was never studied any post-harvest physiology of Mogra, but that you can go back to, you know, one of the advantage to your generation. I mean, I consider myself of a gone generation. So we didn't have this Google Scholar and all that time. Now you can just Google question, for example, what temperature is ideal for storing Mogra buds or jasmine buds, for example. You will get immediately some reference, and it said to us that between 2 to 8 degrees Celsius is something very, very ideal. So then you can replicate, you can do your studies, but at least you have some reference that you get. So we had this. So we have seen. So with this, I'll come to my second case study, and this was also, as I said, a spin-off of a master's project here. That this particular student happened to talk to a seed biodiversity expert, you know, in a place called Jawahar. He went to an NGO called BAYF, Bharatiya Agro-Based Industries Foundation, which is an NGO, which is a big NGO. And there the seed biodiversity expert, you will see again in another video clip, he said that, look, in the science of seeds, shortest time that you need to store seeds is 1.5 to 2 years. Medium is like between 2 years to 4 years, and long-term storage is anything beyond 4 to 6 years or something like that. So for me, like a teacher here in IIT Bombay with like this, you know, I'm saying not knowing much when I say this, not knowing much outside. So then we said that, you know, why does the farmer need, for example, to store that long? Next year you have the crop, you can just pick up from that whatever he has the harvested. But no, for example, they have in the seed science, they have what they call it as breeder's seed. So in simple technical words, what it means is that seed to be called as seed, you must have a good germination count. In the sense that if the farmer takes 100 seeds, you must at least 50 to 60 must germinate, must grow. Otherwise, he's putting all his efforts to sow them, water them, you know, look after them, and if not even 60 have sort of germinated, then his efforts would go. So there is a regulatory agency also. The seed industry, for example, is required to put on their label, on their packet what they sell is like what is the minimum germination count. So based on the crop, let's say if it is soybean, then it has to be 65%. If it is paddy, it has to be 75%. If it is onion, for example, 85%. Because onion seeds are very, very expensive. You know, this time I will not ask you the cost, but it's something like 2,500 rupees per kilo. Onion seeds are 2,500 rupees per kilo. So a very, very precious, and then therefore the germination counts minimum required by the regulatory agencies are of this order. So so what we sort of did and which is narrated in this video clip is again as an end-to-end solution. We went to the sort of the end users, we talked to the farmers, we sort of understood their problems as to what is the problem. So you have some kind of a here as a part of that survey. What do you see here? In a year's time, when the paddy had everywhere more than 80% of germination counts in its first year, in the subsequent year coming to 0, 3%, 6%, no way, right? You can't. See, for example, if you look physically at the seeds, you won't be able to see that its germination count would be that low, and if the poor farmer takes these seeds and sort of plants, he has he has lost that season and all that. So this was a problem. As a part of problem identification, we did this. And then what do we learn again from the science of storage of seeds? So x-axis you have the moisture content here, and you have the temperature here. So what we see here, I think you are not able to see, so this is in between this A, B and here, this white is something is a safe domain. You would not have any insect infestation, you would not have any falling germination, you will not have any fungal attacks. But as the temperatures go up, okay, beyond 20 degrees Celsius, and as the humidity goes up, you are likely to get all these problems as seen here in this graph. So this is what we call something related to moisture content is called water activity. Water activity is free water, which for example is, so no sooner it goes beyond something, so you have a relative rates of reaction. So these are degradation reactions. No sooner your water activity goes beyond 0.7, you would have all those moldies, bacteria and all that, and then the higher organisms like insects come into play. Can we play that next video on the seed? So you will see in the video that and trying to explain why, for example, from 90% they went to 3%. In a year's time, when they stored the seeds, this is seed storage. Yeah, that one. Right, please play with, open with media player, or it's okay?
Agriculture, with its allied sectors, is unquestionably the largest livelihood provider in India, more so in the vast rural areas. It also contributes significantly to the national gross domestic product. Indian agriculture and allied activities have witnessed a green revolution. Here are some of the traditional methods practiced by the farmers. The seeds are gathered at one place and allowed to dry in the sun. Another method involves using ash as a preservative to treat grains such as grain sorghum, pearl millet, cowpeas, mung beans and groundnut. Here, some plant fibers are kept over the mung beans and ash mixture and sealed with cow dung. Earthen pots made of clay are also used to store seeds. Walls of the pots are coated with clay and the mouth of the pots are closed with plant fibers and stiff cow dung. An alternative method preserves air potatoes and melon, pumpkin and bottle gourd fruit variety seeds in baskets. These baskets are left to hang from the ceiling for about 10 months. Grains such as cowpeas, mung beans and pod seeds can also be stored this way. Seed storage is an important process in maintaining the viability and vigor of the seeds during the storage period. The high moisture content only encourages fungal and insect problems. The inadequate storage conditions can further lead to the loss of seed quality. Let us now hear about the key issues of storing seeds and the expectations from the farmers in the Jawahar region of Maharashtra.
आम्ही ते हे भात आम्ही झोडतो आणि मग नंतर ताटकामध्ये ठेवतो आणि बियाणं एक वर्ष राहतं त्याचे दुसऱ्या वर्षाला राहत नाही मग ते अडचणी आहेत त्या कशा ठेवायच्या कशा पद्धतीने
जूनमध्ये जी बियाणं जर घेतलं ना ते जूनमध्येच पेरणी करायची दुसऱ्या वर्षात ते चांगलं राहत नाही खराब होऊन जातं किडा वगैरे लागतात
कणगीत ठेवतो ते एक वर्षाच्या आतच वापरतो मग नाही उगत
एकूच सालात जर उंगत मग दुसऱ्या सालात उंगत नाही मग त्याला पोकळ येतात कीड लागतात
तुमच्या यांच्यानी काय भेटलं असतात तर आम्हाला ठेवायची सोय
तर आम्हाला अशी अपेक्षा आहे तुमच्याकडनं काहीतरी मशीन वगैरे किंवा काय असेल म्हणजे जवळजवळ 3 वर्ष तरी आम्हाला टिकलं पाहिजे ते असं बियाणं अशासाठी आम्हाला काहीतरी तुमच्याकडे काय उपाय असेल त्यासाठी तर बरं होईल.
The associated NGO group in this Tata Center project is Bharatiya Agro Industries Foundation, popularly known as BIAF. It is engaged in seed conservation efforts in the Jawahar region of Maharashtra. BIAF stores seeds for the community-based farmers through seed banks to help them in seed preservation. BIAF has now suggested better solutions to be developed for individual farmers. This is how Tata Center's seed storage units have identified a substantial need.
Because of unpredictable rainfall situations, there is a need to revive this diversity for food and nutritional security, and this program should be community-led program for conservation and revival of diversity.
A seed storage unit of 200 liters capacity has been designed, developed and tested in the Tata Center's food lab as a part of the MTech research project by a Tata fellow. This unit is expected to provide a constant temperature of 15 degrees Celsius and also ensures a lower relative humidity below 40% inside the seed storage unit. These are suggested storage conditions for medium-term seed storage. The efficacy in storing the seeds for 10 months duration is shown in the graph that outlines the benefit of using the suggested temperature and humidity conditions inside the seed storage units vis-a-vis the existing external conditions of seed storage. Germination count before and after storage is an important parameter that indicates the performance before planning a wider dissemination of the technology developed. The germination test is to assess the seed quality or viability and to predict performance of the seed and seedlings in the field. Tata Center tried a germination test to check the germination count before sowing the seeds. A pilot activity has been undertaken to test the units at 15 different agroclimatic conditions across the state of Maharashtra. The IIT Bombay team expects to make a larger impact in providing a seed storage system at the decentralized level.
So, as you can see, for example, this is an ongoing exercise. Last Saturday only we had a workshop with these seed scientists and the people who are sort of working in agriculture universities and seed company, for example, their representatives came and gave us some kind of a feedback. So, what is the contribution by a technology institution here? See, the farmers themselves and let alone the farmers, but even the university scientists in agriculture would not know. For example, you can have a data logger of this size. You saw there was a data logger, right? The small black device that you had, you can keep inside and you can log 1 year data, okay, inside the seed storage unit and just validate, for example, whatever were the design conditions, right? We had two design conditions. One was the temperature has to be in safe zone. Second was the relative humidity. So, what happens with these biological commodities, actually it cannot stand diurnal variation, din mein raat mein, see you can have a temperature delta T of something like 15 to 18 degrees Celsius, right. In Rajasthan, for example, which is a arid region, in the daytime you can have anything between, like in the months of summer, 35 to 40 degrees Celsius, right. And in the night time, in the arid regions, the temperature can go down as low as 16, 17, 18 degrees Celsius. So, that delta T motivates the relative humidity conditions, and change in relative humidity sort of affects the moisture migration, and therefore, we had two important parameters actually which we tested. One was the moisture content of the seeds and second was, no, for the seeds to be called as seeds, I said something is very, very important, germination count, right. So, we want to test, for example, that those seeds must qualify for its moisture content. And why moisture content? Because as we have higher moisture, the science of seeds, I mean those graphs if you had seen, then the moisture content beyond something would then provoke the whole mechanism of the higher moisture would bring in microorganisms, those microorganisms will bring the higher organisms like the insects. Kida lag jata, ghar mein bhi, not seeds, but if we store food grains in a coastal area like Mumbai, we don't ever, my wife would never ever buy her wheat or rice, wheat she does not buy anymore, now she buys flour, atta. But rice, for example, she would never ever buy for more than 2 months, because what happens in the coastal regions, the outside relative humidity is in monsoon. Now, if you sort of had a sensor and you go out on the road, the relative humidities would be more than 90%, far ahead, far high, far too high. So, these commodities, because they are low moisture commodities, they would be hygroscopic, these biological materials are hygroscopic and they can sort of absorb moisture and all that mechanism of microorganisms, higher organisms and then deterioration in terms of its sort of the important parameter of. So, how do you relate these multi-parameters, for example, to something that we want? A desirable output is we want seed to be stored for 2 years, 3 years, 4 years, and it should not during its storage absorb moisture and get into these microorganisms, as I said, fungus, and then the higher organisms like insects and things like that. What is the cost? Oh, so right now it costed us about 15,000 rupees when we made some 15 of them. So 15 units. So we 200 liters. So it's like your domestic small fridge is about 300 liters capacity. And the question people could ask us is, why not use a domestic refrigerator, which gives you something like between 4 to 8 degrees Celsius. One is we don't need that low temperature. We said from the science or the seeds handbook, what it said that you need between 16 to 20 degrees Celsius is largely good enough to store them. So the domestic fridge works on vapor compression systems, as some of you who are mechanical maybe would know that this is a, you use some refrigerant gas and so it's a vapor compression cycle and it consumes therefore a higher power. See, any domestic fridge would have something like, if you can Google also, you will find out it's something like 250 to 300 watts, rated as that. And it's something like on for almost 10 to 12 hours in a day. So you can hear also, you go next to fridge, those who are not mechanical engineers or those who have not studied refrigeration cycle can go near the fridge and find out, you have those condenser coils behind. These days you don't see them coils physically, but you can touch the walls. The walls are found hot, right? So for example, they are something like 10 to 12, and you can hear the compressor also. So here the USP of this particular device, it's like consumes something like maximum 80 watt and it remains in active position for maximum 2 hours. Maximum 2 hours. So the design part is out of 24 hours, 2 hours in an active mode it will consume 80 watts. And in the passive mode, just to keep the fan on, for example, you see, because the TEC is of the half the size of this, the thermoelectric cooler. I told you about the Peltier effect, the reverse effect of thermocouple, right? Somebody defined thermocouple. So yeah, so what we have done is actually we have kept 5 different kinds of seeds here. So we have kept paddy, we have kept maize, we have kept onion seeds, those are smaller ones. Peanuts are slightly bigger, or groundnut as they are called, are of higher size. So I don't know what seed you had in mind. Well, potato are, you might know that even those which are not used for seeds and for consumption are stored in cold storages, right? You have potato cold storages. Seeds also can be, yeah, seeds are smaller, right? But I don't know what size you can keep. I mean, like the yeah. Cut and after germination, they are cut into pieces. So in potato, if I understand, long time back I had just read about, there are 2 kinds of propagation methods. One is called true seeds. True seeds means actual seeds, and another is vegetative propagation. That's what you're talking about. Vegetative propagation means like sugarcane, you cut part of the sugarcane and plant it, or like rose, for example, right? Rose also, it's vegetative propagation, not seed. But the TPS, the true potato seeds, is also something which sort of people are now sort of have devised and follow both methods. So I'm sure when you have sort of temperatures like this, but as I said, they are commodity specific, right? When we said Mogra, what was the temperature? Anybody recalls? 2 to 8 degrees Celsius is something which we sort of is Mogra specific. For seeds, we said 16 to 20 degrees Celsius. So for the potato slices, I would not know, but I think it could be in that. And let's say if you, the sort of, the equipment manufacturer tells that right now we have put 1 TEC engine, thermoelectric cooler, you can put 2 and get the lower temperatures also. We can get the lower temperatures, like when we are trying to now think about I mentioned about the workshop that we had last week on the, at a place near Pune. One of the requirement was, can we diversify its use, like you are saying, can we sort of, because what happens is in all those agriculture machinery economics calculations, one of the thumb rule they say that it should be minimum 1000 hours used. Okay. So here, for example, that the inventory management for the seeds, that you would need only once in 3 months, once in 6 months, once in a year, that you would open, take out seeds and give it to the farmer, or they are used for sowing or something like that. Whereas in fruits and vegetables, you say every 2 days, 3 days, you would be sort of your inventory you will have stored product going into the market and the new product coming in for this one, So throughput, as we call it in engineering, throughput in seed storage system is very, very low in the sense because you want to store it for longer period of time. So the question that people are asking is that can you sort of, during the, when we still have the fruits and vegetables, although they are not as value added or as sort of, as I said, 2,500 rupees per kilo for onion seeds, fruits, vegetables will never ever be that, 30, 40 rupees would be there, sort of cost to the sort of, we pay more higher. But so that was, these are some of the questions that we are sort of, so this is the data logger which I mentioned to you that you can keep it inside, and this is something which sort of, helps you validate your technology, helps you validate your methodology. Compares to something is available in the literature as we showed you in terms of graphs, and have you sort of, create some kind of an evidence that, you did maintain the relative humidity below whatever that 40, 45, or at least you did not have shocks, like what I mentioned you about the diurnal variations, right? Daytime temperature, nighttime temperature, daytime relative humidity, nighttime relative humidity and things like that. So these were the units that were tested, and this is sort of explains why, for example, we are explaining the USP of the designed equipment is below 80 watt it's consumed and gives you something. So normally we do not expect the temperatures to go beyond 40 degrees Celsius outside. You have Nagpur summer kind of a condition, you may have 45, then you will have to sort of compromise. Your inside temperature could be something like 20, 21 degrees Celsius. And that's what so any sort of dissemination of the technology, people in agriculture, food domain or seeds domain would ask you, but have you tested it in different agroclimatic zones? See, for example, no seed unit would have its shop in a coastal area. No seed company has a shop in coastal area. What is the reason? Pardon? Right? The relative humidities are higher, and as we said, these around? All around 12 months. Yeah, so humidity is higher, so about 70% in monsoon periods, about 90%, and therefore these seeds which are dry commodities would tend to sort of, because all of the seed companies cannot afford to have those ACD systems, air conditioning and dehumidification systems. The larger, some of the seed companies may have, but the smaller seed companies may not have these utilities or these kind of facilities. So they would want to store it in a normal ambient condition just under the shed. So there you won't be able to. So, but the advantage of this decentralized unit, for example, you can also, you saw in the map, right, in the video film, there was a map shown. Some of the units are also tested here. Some of you know Bombay geography, there is a place called Bhayandar. I mean, you have a creek of Bhayandar. So we have one unit there in one of the agriculture research institute there. Right. So these are some of the results, and it's, as I said, so this was in, I think we have one unit at IIT also, and these were sort of moisture content. So 12% is something which we said gives you that when you have the germination counts in the traditional, we had kept actually aside the traditional. So what was wrong with the traditional system? I mean, if you have a clay pot, people are practicing that. What's wrong with that? Right, it is porous, and there would be a moisture migration, humidity migration from outside. So this is what sort of brings this. So these are the sort of, so this is somewhere I was saying, one is in Dapoli, and then one is here near Thane, that agriculture institute which I mentioned. These are the, okay. So this is what we sort of creating an evidence, showing them. So we had a very tough questions from the seed scientists the other day, last Saturday when we had the workshop. One of the question was, like she said, for potato, they asked that can you increase from 200 to 500 liter, from 200 liter to 500 liters, because so the bulk density of all these commodities is something like 500 kilograms per meter cube. So 500 liters is half a meter cube. So you should be at least, they said, able to store about 200 to 250 kgs of seeds, because then 10 farmers, 20 farmers, 30 farmers are covered. Okay, so that was a question that, so we can't as engineers, we can't immediately say that yes, scale up is okay or something like that. We said that we will explore. In order to maintain those design conditions of 16 to 20 degrees Celsius, relative humidity less than 40%, whether you need 1 TEC, 2 TECs, what would be the power consumption? We already mentioned to them that because of this village the village feeder power fluctuations, like we often see, for example, the power can go from 160 to 260 volts when it is said that 220 volt is something which should be available. You always have these kinds of, not only power fluctuations, but you have something like what they call it as power breakdowns, load shedding. You have heard of that? Load shedding, load shedding. So it's like designed, on a given day, like Thursday, there will be no power or something like that. So we ourselves faced in one of the unit, for example, which is a remotely located location, somewhere, BIF's unit, for example, 2 times we had the PCP which was conked off, because everybody does not have a power stabilizer. There was a time that everybody uses a PC, for example, you used to have but now for your laptops, I think even if you go to Timbuktu, you would not require really a power stabilizer, right? It can sort of. So how do we make the unit, how can you make the unit rugged so that it can sort of accommodate all this? So let's say, for example, if there was an intended power shedding for 3 days, can we have adequate insulation, right? In refrigeration and air conditioning, they teach you that, what should be the thickness of insulation, so that when you have inside about 20 degrees Celsius, outside is 40 degrees Celsius, how long, for example, if I have a load shedding of 3 days, can I still maintain that desired temperature? So all these questions, all these issues are there. So this was like a story of end to end in seeds. What I'll do is, I think it's close to 11. I will not cover the other 2, this one perhaps Professor Mahadani will cover this sugar. Just a few things I'll just tell you about this. As I said, the non-engineering or non-technological institutions, they have always some hang up about numbers. For example, the pediatricians with whom we worked in a municipal hospital called Sion Hospital here in Mumbai, which is near Dharavi. In fact, next to Dharavi, their hospital is located. So, for example, that doctor's team really had a hang up about, but how do you sort of do a, sampling? You have 300 Anganwadis, which one will you select? How would you be unbiased in terms of your sampling? What sample represents the population of those 21,000 kids? As I said, we could not take 21,000 kids, because providing foods to these 21,000 kids from an institution like ours would have been difficult and difficult to monitor. Because what we did was, like, we did sort of, as I said, took only the kids which were moderately malnourished, not severely malnourished. The severe malnourishment is called as a medical condition. We are not allowed, as non-medicos, we are not allowed to sort of treat them. There is some kind of a set of protocol to treat them. So this moderately acute malnourished kids, the objective was, can we design a food formulation and get to sort of test that if you give it for some number of months, let's say 3 months for example, a particular kind of a food, do you see any change in their weights? Or do you see, for example, that after 3 months of this intervention by feeding these formulations, what percentage you could bring them out of the moderately acute malnourished? What percentage you could? So all this, for example, is a role of a non-medico here, and therefore we wanted to prove our point that interdisciplinarity is powerful. I always cite this example to my students here. When you go to villages or when you go to communities, people don't say that, I need a civil engineer, or I need a mechanical engineer, or I need a thermal engineer here. They said that, there is the water down here 200 feet, my farm is here, how will you sort of get that water to my farm? That's their problem definition. And it's for example, us to sort of identify as to how do you sort of make a problem definition, and within a period of 1 year, 2 years, 3 years, as a part of whatever, academic study, or by the way, one of the study that Mogra that we talked about was funded by a collector. Palghar collector, for example, he said that, well, you are doing something to arrest seasonal migration, and this comes under my domain. How can I sort of use your tool or technique to store Mogra, give a better farmer's outgo? Right, as we mentioned, 40 rupees से अगर उनका 400 रुपया भी होता है, right now they are getting 40 rupees out of that 1,200 that sale price is. So, from 40, even 100 rupees, 200 rupees, how can you give that? So, then the Palghar collector gave us, funded us part of the project. Okay. So, I will stop here and we will wait for the questions. You need a mic? Huh?
What were the behaviors were recorded or observed to check that they were malnourished?
Behavior of what?
Of the children.
So, let me take it little backward. The first study that we did was actually on the SAM children. But since the doctor was there, as I said, the ethics committee allowed us to go ahead because there was a doctor in the team. So, there one of the feedback was or the gold standard or the standard of protocol that they follow is like 2 weeks you have to give a certain nutrient rich food which is called RUTF, ready to use therapeutic food, something which is therapeutic, you know, like a nutraceutical supplementation or something like that. So, there the feedback was this, since this RUTF was sweet and the child was asked to eat every day, day in and day out, for example, 2 cups, 3 cups of this food, it was too monotonous for the child. So, that was the one learning for us when we did this facility based or a hospital based trial. And so, one of the learning was, say, what we had was these malnourished kids, all said and done, would have to, like, howsoever sort of, you know, they say sugar coated medicine, you know, it has to be sort of, you know, appealing in terms of test. Now, when we wanted to do this Dharavi kids and we want to give 3 months put together, we had to bring this diversity. So, we had a pack called 7-in-1. So, every day they would, and we tried to sort of stay close to the ethnic habits of eating. So, we had something like Zunka premix. Zunka is made out of, you can call it besan, for example, in Hindi. Then we had something like, so we had some, out of 7, we had some 4 ready to eat, like matris and all that. And all of them were fortified with sort of, you know, micronutrients. And it seems, although micronutrients are in small amounts, it has a definite role in that particular age group, which sort of lasts them long in terms of building their immunity against diseases and all that. So, since we had 7-in-1, the children did eat. So, we had that kind of a survey in our, a question in the survey that did you eat? If you ate, what portion of it? Did you eat 50% of it, 70%, 100%? So, we wanted them to eat 100% because it was only 1/3 of their required nutrition. RDA, as they call it, recommended dietary allowance. Like we, for example, we need about 2200 to 2400 kilocalories per day. So, these children in their age, for example, require something about 1400 kilocalories per day. What our food provided was 1/3 of that. And in the domain of nutrition science, it's called as supplementary food. So, you don't provide all that 1400, you give something like 400, 500 kilocalories through this supplementation. But you get 100% of your micronutrient supply, like, you know, all your calcium, magnesium, iron, for example, which is important and which allows you not only sort of, you know, immunity against diseases, but also some cognitive. So, because it was 7-in-1, something like 80%, 90% of the kids ate this food. So, that was first thing very, very important, that whether they ate. You want to know about behavioral things. So,
before eating this product and after eating the product, what are the changes? The changes were qualitative or quantitative?
yeah, so like what we typically said was, say for example, we wanted to study as a function of time, what was the growth, okay, and the growth was measured in terms of weight plus height. Okay. So, let us say this is something which is what we expect as a band for normal growth, right. So, this is in biology you never have a point, this one. So, this is something what you called as a normal range, and these undernourished or malnourished children are low birth weight, they have a low birth weight and they are sort of, you know, laggards, this is how they do. So, our objective was take those 3 months of period here and try and take them into this band. Okay. And so, we had what you call as, like we typically call this as Z scores. So anything below, so this is like 0, -1, -2, -3. So those who were sort of between -2 and -3 Z scores in a given period of time, we wanted, and so we had something like 34-35%, which we could bring using this food. We could bring them in this safe bracket, normal, so-called sort of normally nourished, normal population, not undernourished or malnourished. Growth is like their weight and height. You measure the weight and height.
Is recorded. So any other?
No, we sort of did only this weight, height, and there is third parameter which is called MUAC, MUAC, which is like mid upper arm circumference. So between here and here, you take a middle point and measure with tape, and you have these specific tapes to measure that, and we measure that, and then we see their Z scores, how they have sort of weight, height, and MUAC has evolved over a period of time. Yeah? Is it clear or not yet?
So what is the refrigeration technology that you used in that? Refrigeration technology in the freezer for flowers, seeds and seeds for seeds.
For seeds, we use, we called it as reverse of Peltier effect, and which you can Google it actually. This is called thermoelectric cooler. So what you do is, as I said, reverse of thermocouple. Like thermocouple gives you a millivolt output. Here you give the voltage supply here and produce a delta T effect. And as we said, like we wanted whatever. So this thermoelectric cooler gives you something like delta T of about 15 to 20 degrees Celsius.
So like how much it is energy efficient?
That's what we said, that if you had used for a similar volumetric capacity, and if you had used a vapor compression system using a refrigerant, it would have sort of required 2x power. Like as I said, your domestic fridge, you can Google, it's about 250 to 300 watt. This consumed, as we said, less than a unit, let's say 0.75 of a unit, a kilowatt hour. Is something was the consumption when we measured the sort of, we did not put any power consumption meters like we had for temperature and relative humidity, but this is what is the sort of designed this one, that it will consume less than even if you worst come worst is maximum 1 unit per day, and that unit of electricity costs about 8 rupees, 10 rupees. Vapor absorption system. You're saying that can we use a vapor absorption system? Yes, in the sense that
I think it is more.
Yeah, but the sort of it would become a project by itself to maintain that vapor absorption system. See, ammonia water, for example, has been tried, but it's not really as rugged as the vapor compression system. And as in terms of use, there are in research you see the vapor absorption systems like ammonia water.
Yes, and what is the life cycle of this refrigeration age?
Which the TEC or the TEC?
The whole TEC.
TEC. So the original equipment manufacturer says that is something like 5 years.
Okay.
Is minimum it should give you that designed delta T. Right, and the others, for example, is like a fridge. The bahar ka baksa jo hai, there is a steel insulation which is standard, which they have used, what they use in a domestic fridge. So that should not. The only thing what you sort of could have a moving part here is the fan. And TEC is not moving, but that's what the characteristic may change. Yet to see. We have installed it last year, August. We distributed at these 15 places, and we are sort of I mean, they feel that the equipment manufacturer feels that, and therefore in September, October, right, I think Saili is not here. So, so for example, they want to visit these places and want to see, for example, really the power consumption, because something has sort of, some dust accumulated on the fans, for example. The user would not have cleaned it, so that could perhaps increase the power level or the sort of, that would normally come into the temperatures monitored, because some of the places we have 24 degrees
I
Celsius.
think thermoelectric refrigeration is, the cost of thermoelectric refrigeration is quite high. So is it
15,000 rupees. A domestic fridge vapor compression costs around 24,000 rupees. I don't know how much it will cost in your place, but here it's about 24,000 rupees. So, and there also I think compressor life is 5 years only. The compressor, the life that they guarantee is about 5 years.
Good morning, sir.
Yeah.
Sir, I have a statement or a thing to share with you. I am basically from Uttarakhand, and there is hilly areas, and the problem of migration is also there. And there is a fruit called Malta, similar like oranges, taste is sour. So I think
Mandarins also is something like mandarin. They called mandarins. Mandarins, small oranges. Okay.
it is big.
Big one. Okay. Okay. Okay.
Size Kinu is hybrid.
Kinu. Okay.
Kinu is hybrid.
Okay.
And Malta is different.
But in the same kind of a genre or same species or something like that. Citrus. Okay.
So there is a cultivation of that fruit in large numbers. So can there be a food processing of that Malta and we can change it into juice type thing? It can compete with the in product terms. It can compete with Ruabza.
With the Ruabza. Okay.
So it can compete with Ruabza, or further we can take it from the Ruabza to fruit beer type things. So for that.
Right. So what I would strongly, immediate suggestion on that would be try and meet the unit holders of NOGA. You know, we have NOGA is Nagpur Orange Growers Association. You know, Nagpur Orange Growers Association. So if you identify, let's say, a farmer or a group of 2, 3, 4, 5 farmers, if they can sort of, you know, set up and have an interaction with this NOGA. NOGA is making all those, you would have heard those orange juices, right? Pulpy and all that. Of late you get not completely filtered, but you say a lot of pulp. People prefer these days, you know, some mouth feel. So you have a pulpy orange or something. So they have set up units in Nagpur. So Nagpur in Maharashtra, for example, is known for oranges, right? Is known for oranges. So they have these units of different capacities. So what capacity? First thing is you will have to see is what capacity they would like. Then, for example, what is the kind of equipment? Because equipment perhaps is will not too vary. You know, I mean, you would have something decorticating the seed, then you know, making a juice out of it. The most important thing is how do you stabilize its shelf life?
Yeah.
Because ऐसे अगर orange हम खोल के रखते हैं तो next day you will have it sort of, you know. But if you want to make it into a juice, what are the sort of you know, unit operations that you do?
Before 4 to 5 years, the government supported this making of juice from there, but that project didn't take off.
Did not take off. So you might like to learn, because what I heard was one of the large units there, which was on a completely based on imported technology, also started and shut down within 6 months.
Yeah.
So NOGA would be the right people, because they have different scaled plants. So they would they would narrate you the sort of, you know, something that will work, something will have some challenges, you know. So those who are serious, I mean, if you can sort of you know, accompany them as a engineering strengthened person, I think it would be a good idea.
Okay. So NOGA will be a right.
NOGA would be a right. So you can just write out. They may have a website also. Nagpur Orange Growers Association.
That Mogra storage machine, what we have seen here, that can also be used to store the flower like marigold and others, or specifically it is useful for the Mogra storage?
That's what, as I said, the collector Palghar has now asked us. I mean, he is giving a grant for phase 2. We have just, I mean, like in winter we have to do in the phase 1. We've done it in March, April in the summer. And there is a second crop which comes in winter, which we want to test. But he has put in his wish list, same as you, can we sort of do marigold, can we do roses, for example. So today I don't have an answer. As I said, 2 to 8 degrees Celsius for Mogra was known to me because of the literature review that we did. So for marigold, for example, what is the good? So as I said, some commodities do get cold injuries. Like bananas, I gave you an example, right? You can't keep it in the cold storage. So, yes, I mean, we would, in the phase 2, we are going to explore the additional commodities which would sort of, because see, as I said, March, April, May, Mogra season over. Then what happens to this cold storage? If you want to sort of increase its usage, you would like to diversify, you would like to sort of, right?
So the cost is 1200. The cost is 1200 because of this like less duration of production and round the year usage.
I think costs and all that, I think, is a dynamics of demand and supply.
So that is 1200 is because of demand.
Because of non-season, yeah, obviously. Now it's a no season period. During season, it will go to 600 rupees also.
Okay.
600, 400 also during season.
So that is why storage is a bigger challenge.
That's why, for example, in the sense that major push for us to develop this technology and this one was to sort of remove that drudgery. And it's also called as in this agriculture economics as a distress cell. कि बचा है अभी कुछ क्या करूँ मैं कुछ दे रहा है 40 रुपया पर किलो मैं बेच दूँ. But if this is a cold storage, you can sort of 48 hours you get a shelf life. Then I can sort of not be forced to do this distress sell. अपने घर में रखा है उसने फार्मर में ही जो भी बचा मतलब बेच नहीं पाया, he can bring it back, send it to Nashik, send it to Dadar, for example. If Dadar is not sort of giving good market, he has another option to send it to Nashik. Yeah. Okay. Thank you. Thank you.